Here we are going to discuss about the confusion matrix. Confusion matrix is basically a performance evaluation tool which is used to classify the problems in the machine learning, data mining, statistics, and etc. It gives the summary of the performance performed by the model by comparing the actual data with the predicted data. It shows not only how many predictions were the correct, but also what kind of the mistake the model has made. These are the main goals of the confusion matrix. The first one is it measures how well a classification model has performed. Second one, it identify the types of error, which means it identify either the prediction made by the model is true or false, positive or negative. The error are of two kind here, which are false positive and the false negative. Third one is it go beyond the simply simple accuracy. The fourth one is it provide the basis for important metrics like precision, recall, etc. These are the importance of the confusion matrix. This includes it reveals which classes are confused. It helps in the analysis of the error. It helps in the crucial for imbalanced data set. It supports the decision making in high risk domain. This is the basic structure or graph for the confusion matrix. In this there are uh, in which there are two type of data. First one is the actual data and the second one is the predicted data. If any result is predicted as positive and the actually it is positive, this then it is called as true positive. If any data is positive but it is predicted as negative, then it is called as false negative. If any data is actually negative but it is predicted as positive, then it is known as false positive. And if a data is negative actually but it is predicted as also negative, then it is true negative. Basically, these are the elements of the confusion matrix. First one is the true positive condition. In it, the actual data is positive and the model predict it as positive also. Then we can say that here the prediction is correct. For example, if any person has a disease and model predict it as the diseased person, then here the prediction made by the model is correct. Second one is false positive. In this, the data is negative and the model predict it as positive. In this condition, the prediction is incorrect. So here we can take an example. If a healthy person is predicted as sick by the model, then this will fall under the category of false positive condition. The third one is false negative condition. In this, the data is positive, but the model predict it as negative. Then the prediction here is incorrect because both the data are not are not are basically not same here. So here we can take an example such as if a sick person which is predicted as healthy, then this will fall under the category of the false negative condition. The fourth one is true negative condition. In this, the data is negative and the model also predict it as negative. Then this type of prediction is correct. Here we can take an example like if a healthy person is predicted as healthy by our model, then it will fall under the condition of true negative. There are three types of formula used here. These are the three basic formula which are used in this. First one is the accuracy, second one is the precision, and the third one is recall. Accuracy, it gives the overall correctness of the model. The formula of it is TP plus TN divided by TP, TN, FP, and FN. By using this and putting the value of these elements, we can find the accuracy of the data. Second one is precision. Uh, the definition for the precision is out of all predicted positive, how many are actually positive. The formula for this is TP divided by TP plus FP. By putting the values here of TP and FP, we can find the result for finding the precision. The third one is recall. Out of all actual positive result, how many are correctly identified? The formula for it is Tp divided by Tp plus Fn. By putting the values in this also we can find the result of recall.